I'm Robin, and for today, we're gonna answer a sample shortest path problem, particularly the concept of the traveling salesman problem. Suppose a salesman based in City A has to make a delivery for each four towns before returning to City A. Given the routes and traffic conditions, in what order should he make his delivery so that his total traveling distance is a minimum? So the figure is displayed below where the vertices are connected along with their respective distances. So we were informed that the salesman is based from on city A. So we'll start from city A here. So let's start off by getting the total number of permutations. So our permutations would come from n minus 1 factorial, where n is the total number of vertices in the figure. So we have 1, 2, 3, 4, 5. So we have 5. Substituting 5 into the equation, 5 minus 1 factorial. So 5 minus 1 is 4, so 4 factorial. 4 factorial means 4 times 3 times 2 times 1 is equals to 24. So we have the initial 24 permutations, but we can see that from point A, there are only 12 unique, let's say, paths, because we know that some of the Hamilton circuits that we will form upon choosing the respective paths with the idea of not like repeating the same vertices when hopping on to one another, we can see that some of these Hamilton circuits might be the same. So if we based from city A or point A, there is only half of the permutations we solved initially. So we have now only 12 permutations. So our total is 12. I mean, yeah, we could have 24, but it would be much easier for us to compute the total number of minimum distances, since some of these distances would be the same from each other because of their they call this their respective paths. So let's say we have A, B, C, D, E, A. Then later on we get A, E, D, C, B, A. So this both of these are only the same. So it is not necessary for us to write this repeatedly so that we also won't get confused. So after getting the total permutations, we get the permutations of the vertices based on the number of permutations we got. So first we have, let's list this down so that we would be organized in our values. So let's put here permutation, then we put here the length. So for our first, wait, let's just change the color. So for our first, we have, let's look at our figure, A, B, C, D, E, and A. So when writing down the circuits, note that you cannot go to another vertices twice when you plan to direct a certain route. So all the vertices should only be what do you call this? All the vertices should only be um navigated through once. So um you cannot go to each vertices twice or more. So for our first, we have A, B, C, D, A. Second is A, C, D, E, B, A. So I'm just gonna list down all the 12 permutations so that we can get on with it. So you try also to list down based on the figure. Then there we have it. So we have our 12 permutations ranging from the first point, which is city A. So next we'll proceed with finding the length for each Hamilton circuit. So for our first one, we have A, B, C, D, E, A. So let's start off. From A to B, we have 10. From B to C, we have 35. So this adds to 35. From C to D, we have 30. From D to E, we have 50. And from E to A, we have 25. So this adds up to 150. So this applies to all the Hamilton circuits. So we just also find their respective lengths with accordance to um, the vertices, the arrangement of the vertices. So let's repeat the same process. A to C is 15 plus 30 plus 50 plus 30 plus 10, which is equal to 135. So just repeat the same process for all. We'll just write down the lengths. 20. So now that we have acquired all our permutations and their respective lengths, and we have computed their overall length, the last thing for us to do is to identify which Hamilton circuit has the shortest total distance that ends with A. So let's assess our length. So we can see that the permutation or the path A to E to D to C to A has the most shortest distance with 125 in total. So we choose this Hamilton circuit as as our route or path for the traveling salesman. So we can say that the Hamilton circuit, let's change this to black. The Hamilton circuit of the five towns, because we have five overall vertices, starting and ending at A, that has shortest total distance is A, E, D, C, A. So that's how we do and apply the concept of the traveling salesman problem when dealing with these types of shortest path problems.